The Indian Association of Structural Engineers, also known as IS-Struct-E, was conceptualized and constituted in the year 2002 by a group of senior professional structural engineers from all over the country. IS-Struct-E is registered under the Society's Registration Act 21 of 1860. The Indian Association of Structural is a national apex body of structural engineers in India, with a mission structural engineering profession and cater to the professional needs of the structural fraternity. In the short span of 2 decades, association has attained an eminent position in the professional field. Its membership is valued very highly in the profession. Since inception, IS-Struct-E has been led by eminent structural engineers like late Shri Mahendra Raj, late Shri Shri Kumar Ghosh, Shri Subhash Chand Mehrotra, Professor Mahesh Tandon, Shri Alok Bhaumik and Shri Manoj Mittal as its president. IS-Struct-E is a permanent member of Engineering Council of India and interacts with the government on professional and policy matters related to civil and structural engineers. To expand its reach, IS-Struct-E has collaboration with various international professional like-minded associations and institutions. IS-Struct-E's prime objective is supporting and protecting the profession of structural engineering by upholding professional standards and acting as a mouthpiece for structural engineers in India. IS-Struct-E endeavor to ensure that its members develop the necessary skill in structural engineering and work to the highest standards by maintaining a commitment to professional ethics and standards. IS-Struct-E is actively engaged in organizing several continuing professional development (CPD) courses for structural engineers to help them update their knowledge and advance their career paths. It also conducts refresher courses for young and practicing engineers and student-oriented programs, seminars, workshops, conferences, technical lectures and discussions related to the latest technological advancements, and case studies are also organized regularly for members to enable them to continuously update their knowledge and skill set by interacting with the best minds from the industry. IS-Struct-E's activities are widely appreciated and known for quality technical contents. IS-Struct-E is also actively engaged in publishing its quarterly journal Structural Engineering Digest (SED), code commentaries, professional guidelines, and a monthly newsletter. IS-Struct-E's publications are becoming popular with time. IS-Struct-E has representation in various technical committees of BIS and IRC as well. Its members are actively contributing to National Code of Formulations. In the year 2020, IS-Struct-E started National Awards competition to stimulate interest in the structural engineering field and to promote innovative thinking and creativity. The awards are presented to the winners in recognition of their outstanding contribution to structural engineering in the categories which include Outstanding Structure, Outstanding Structural Engineer, Outstanding Woman Structural Engineer, Promising Young Structural Engineer, and Best Master's Thesis in Structural Engineering. IS-Struct-E is currently operating from 4 regional centers, namely Eastern, Western, Northern, and Southern, having its headquarters in Delhi to inculcate the professional culture and provide handholding to the budding engineers. IS-Struct-E has its student chapters in several leading engineering institutions as well. Membership of IS-Struct-E is open to all civil and structural engineers engaged in structural engineering profession. Members are elected based on their qualifications and experience in different grades as per eligibility requirements prescribed in the bylaws. Each application is carefully scrutinized before electing the members. More information about IS-Struct-E is available on its website www.isstruct-e.co.in.
Vikas, shall I start now?
Yeah.
Uh, Dear friends, I'm happy to introduce our today's speaker, Vinay Gupta ji. He needs no introduction because he is so involved in this field of structural engineers. But still, I would say that he graduated from BIS planning in 1983. And since 1987, he is working with Messrs. Tandon Consultant and involved in planning design of various bridges, flyovers, and other long span, tall buildings. He is associated with many important committees of BIS and Indian Road Congress. And again, I would say he's all rounder and knows and goes in every details of planning. He is immediate past president of Indian Concrete Institute, as well as All India president of Indian Institution of Bridge Engineers. He is also vice president of ACF and Indian Association of Structural Engineers. About the topic, all we know that is a very important topic. The subject is intricacies involved in design and construction of tall RCC chimneys. Now, regarding our moderator, Engineer V.N. Hegde, who is fellow of NAE, he is a governing council member of Indian Association of Structural Engineers. He is a senior professional with a rich experience of over 40 years in the area of design, management, contract management, bridges, energy sectors, marine, hydraulic sectors. Engineer Hegde has been as a distinction of being equally competent and adept in structural design and construction. So now I request Engineer Hegde to take over and start the session. Thank you.
Yeah, thank you, Dr. Dhawan, for that introduction of the speaker as well as moderator, and for your kind words about us also. And I take this opportunity to welcome all the participants to the yet another webinar which has been conducted by Indian Association of Structural Engineers. And today's speaker is Mr. Vinay Gupta, and who has been already introduced by Dr. Dhawan. He has a very versatile experience, as you can see here. He is basically a bridge engineer who is also done the tower design, like the tall chimney designs. And in fact, he was involved in the tallest chimney, which has been tallest in India. Like, we have gone up to 275-meter tall in India, multi-flue chimneys. And many tall chimneys, like 275-meter chimneys, have been constructed in India. So he will be talking about the intricacies of the design of and construction of the tall chimneys. And in this subject is very relevant today, especially from the point of view of the sustainability. All of us are aware, chimney is a structure which is meant for reducing some sort of pollutants into the environment. That is the intention of the provision of the chimneys. Normally, chimneys are provided in the thermal power plants. This is one of the very important aspect of it. In fact, the design and construction of the chimneys is the delight of structural engineers. And as a special structure design, it has been taught in many of the universities. It has the wind sensitive nature, seismic sensitive nature, and also the construction wise, it requires the slip form technology. So technology wise, design wise, it is a special structure. It is not one of the run-of-the-mill structures. And in thermal power plants, as all of you are aware, where the fossil fuels are burned into a conversion of the energy requirement, while burning the fossil fuels for conversion of the energy, there are three the waste products or the side products, what we call it as. One is the pond ash, another is the fly ash, third is the nitric oxides as well as the sulfur oxide, which is the pollutants which gets emitted, which has to be thrown out into the environment, such that at the earlier days we used to think that at the ground level the pollutants effect should be as minimum as possible. Going forward, in view of the climate change, even that situation has to change. All of us are aware. And the sulfur content which is there in the polluted emission while converting this fossil fuel into this the energy, that has to be reduced. These days, that's why we go for the FGDs. FGDs in the sense that fuel gas desulfurized chimneys. That means sulfur oxides, which is there in the pollutant, has to be reduced to the extent possible. That has to be reduced to the extent of 90%. And also in the new design chimneys, there are variations, what they call it's a new design chimney, where borosilicate lining is used instead of the steel or the brick lining which used to be there. And Mr. Vinay Gupta will be talking about the tall chimneys where more complexities is involved. Perhaps this is what I believe, because where the platforms are there nowadays, where the borosilicate lining is there, are the without the platforms or the without the flue liners, we don't have the internal platforms, so the complexities are much lesser. I believe Mr. Vinay Gupta will be talking about the complex structures where a lot of steel liners or the brick liners will be there. Platform construction is there. Jump form, slip form technologies involved in the construction. So I feel that we have got a very delightful lecture to be heard from Mr. Vinay Gupta. Always is a very, very good speaker. All of us are aware of it. And I request Mr. Vinay Gupta to deliver his lecture in his inimitable style. Mr. Gupta, it's the podium is yours, of course, virtual.
Thank you. Thank you so much, Mr. Hegde. You have said so many things, made my life, in fact, easy for this lecture, because the preamble is already given by you. And thank you for kind of introducing me in a way. And I would like to thank the youngest person here, Dr. S.K. Dhawan. I believe he did his PhD at the age of about 70 or 70 plus. And I'm glad that our immediate past president, Mr. Alok Bhaumik, is also with us in this presentation. And of course, good evening, all the participants. I'm glad that you're joining in good numbers. So let me try and start with my presentation. But before that, let me say a few words about chimneys. As Mr. V.N. Hegde rightly said, that slowly the norms for pollution have been changing with time. At one time, the required height of chimneys for powerhouses used to be a little lesser. With the time, it has been increased now to 275 meters, almost like 900 feet. And the way it is rising and the way the pollution is rising, you may find that chimneys becoming taller than Burj Dubai and all that. God knows, nobody can say. But in any case, our job right now is to see how structurally a chimney can be designed, what are the various types, and how it can be constructed, which are also some challenging issues there. So I'll try and just open my presentation. And let me come back to this, and screen share. Yeah, is my screen visible?
Yes. Yes.
Yes, perfectly visible.
Okay, thank you for that. All right, so not moving. Yeah. Yes. So as we see, this is one of the shorter chimneys today, as we say. It's about 300 feet or 90 meters. That is for a different kind of a factory in Mathura. and it's a single flue chimney. We will discuss what is single flue, what is multi-flue. Typically, a chimney would look something like this. You have red and white bands on the chimney, and some of the bands may be as closely spaced as we see in the upper side of the fourth chimney, or the bands can be like this. Now, these bands are mainly for the aviation purposes, that an aircraft passing there should be able to know that there is some object which is at a height, and they have to escape these objects. There is something you see on the left side in this chimney, just showing kind of a pictorially a chimney, which is showing these obstructions. These are called strakes. If you STRAKES, strakes. If we can just keep these words in mind, we will discuss about these strakes also. The various heights of chimneys that we have designed, starting from 80 meters, 85 meters, 90, 100, 130, 150, and several 275-meter tall chimneys. So that is today the maximum height that you have in a chimney, as Mr. Hegde also rightly mentioned. This is one other chimney with a height of, I think, 150 meters, if I'm not wrong. Now, the types of chimneys. RCC chimneys are two types mainly. One is single flue, wherein the entire shell that we see is a flue by itself. And that is it, single flue. Means if you have one boiler or maximum two boilers in the power plant, they can hit into the single flue as long as the gases are of the same type, and they can be exited from this so-called single flue. In case you have more number of boilers, more number of generators to generate the power and boilers therefore, then we require a multi-flue chimney which may have 3 flues, 4 flues, 5 flues, and whatever numbers. But so far we have designed up to 5 flues. Now there is something called a steel flue liner. In the case of multi-flue chimneys, we have a liner which is in steel, and number of course, liners, number of flues or number of pipes that we have are in steel with some coatings for chemical resistance. And in single flue, mostly we have brick flue liner. In multi-flue also, sometimes we have designed, like we have designed one chimney with 2 flues in brick. That was the client's requirement. But otherwise in single flue, it's more or less always a brick flue. We'll see how it is. Now let's look at a typical of single flue chimney. In this single flue chimney, boiler gases would come from here, horizontally enter. The other boiler gas also will come and hit here. And there's a dividing wall so that they don't hit each other and create turbulence. So we have a dividing wall that they come and hit on a flat surface and they start rising up. Come and hit off on a flat surface, they start rising up. Now what we see here are the brick flue. So all this is brick lining. Outside is concrete, that is RCC. In the concrete lining or in the concrete chimney shell, we have brackets at every about 7 to 10 meters. And these brackets, which are round brackets all along the shell periphery inside, they support the brickwork. And this brickwork goes inclined like this, and it meets the other brickwork over it. Inclined, why we make it is, it's more stable when you make it inclined. When you make it just circular but vertical, like a cylinder, then the stability is a bit lesser. Whereas in this case, you get slightly more hoop strength. Now, all these gases, when they go up, they do leave some ashes because they are mixed with some ashes. Although you have cleaned most of it, you have also taken out the this fly ash for mixing into the cement. But those little ashes which are there, they start settling down. And for that purpose, we have a hopper with a hole at the bottom wherein the gases, these ashes are collected and taken out from a truck. So for that purpose, there's an opening here, which is about 5 meters wide and 6 to 7 meters high. Through this opening, the truck enters, takes ashes which are in a through the hopper, they are into a kind of a pot below, and they are discharged. not much at the top. Other thing which is very important about these flues is the diameter. How do you choose? The diameter of the flues, which is internal diameter, let's call it, is chosen based on the exit velocity of the wind, of the gases. Now, these gases must exit at a speed of 25 meters per second or more. If the speed is lesser than that, then for these gases to successfully go out and disperse into the environment will be lesser. So that's one code criteria, that the gases have to come out at a speed of 25 meters per second. If it's just for one boiler, so we have a gas entering from here, this being the chimney, blue one is a shell, red one is a brick liner resting on the corbels, continuous corbels. We also have external platforms for many purposes. We also have a ladder. Now, in this case, since the gases are here, which are hot, we cannot move up from inside. So the ladder cannot be inside, the ladder is outside. From this ladder, you get to the platform, and you can go in when you have to do a maintenance repair. At that time, the power plant will not be working or the boiler will not be working. You see, you notice one more thing here. Between the brick lining and the RCC shell, there is an air gap. Now, this air gap is actually needed for the air to circulate top to bottom. It passes through the corbel also, because corbels are provided with the cutouts. And this air passage, top to bottom and all that, and bottom to top, it reduces the temperatures from these flues or from these inside, which hit the concrete. And there's a criteria, because the chimney shell has to be designed for temperature variation also, from outside to inside. And there is a control of the overall total temperature as well. So this is just one more plan of the same thing that we saw 1 or 2 slides before. You have one entry, you have another entry, you have a dividing wall made in RCC normally, and there's a hopper below, there are platforms, and there's a ladder, all those things. There's a cutout from where you can come out this side, there's a cutout from where you can come out on this side. All right, so I think this is just one more plan. Let me see what is the purpose of this. More or less the same thing. Now, this is the hopper that we were talking about. This concrete hopper has a brick lining again. In brick lining, there are again 2 types of brick linings. One is plain brick lining, simple factory bricks. Other are acid resistant brick lining. Now, what happens is that towards the top, the acid concentrations, which what Mr. Hegde mentioned, are higher. And therefore, to protect the concrete of the shell against the attack of those chemicals, we provide normally in about 10 to 20 meters at the top, acid-proof brick lining. So that brick lining is there on top. In the case of hopper also, the brick line is usually acid resistant. As you see here, it's a 75 thick acid resistant brick lining over the concrete. If you remember, I mentioned that in the corbels which support the brick lining are also cutouts so that the air can pass through. So these cutouts are here, and there's a criteria as to how much cutout area should be there for the air to successfully pass through and provide a temperature control into the RCC shell. Otherwise, the RCC shell cannot take it or the life goes down. So RCC shell is designed for that temperature. So from the structural design point of view, you see that there's a brick wall coming here. There's another brick wall resting on the corbel. This corbel develops a bending moment, and this bending moment goes in this obvious profile that you would imagine as an engineer. Now we come to multi-flue chimneys. Multi-flue means number of boilers are 2 or more. We require several separate flues. Now, somebody may ask me, why do you need so many flues? Why not just one flue for all the boilers? They are all doing the same function. They are running your boiler, they are running the generator finally. Why do we have to separate out? This separation is also done for one reason, that supposing one boiler is stopped, then this area of the flue will be large for less number of flues or less amount of air, and therefore the exit velocity will go down below the critical value of 25 meters per second. So that is also a reason why we have to have separate flues for separate boilers. Where somebody said, one of our clients, that you provide one single flue chimney for 2 boilers. He was certain that either both the boilers will be stopped or both the boilers will work. If they are both working, then the exit speed is 25 meters per second plus. This is one of the most complex chimneys that we designed, having 5 flues. So you can see the entry of various flues into this part. And this, of course, is a plan at the duct entry level. What you see outside is foundation. In a 275 meter tall chimney, one may wonder what the diameters are. The diameter of the shell at this level, at the ground level, will be in the range of 20 to 30 meters. And that towards the top will be 12 to 15 meters, which has to finally take or house these 5 flues. And at the bottom, we need a larger diameter because the foundation is very large. If I don't increase the diameter at the bottom, then the foundation thickness as the cantilever will increase will become too much. And cost of foundation is quite very substantial in the case of chimney. The other thing which is also quite important is that look at the entrance of these gases is more or less close to the ground, maybe 12 meters above and 7 meters above or 10 meters above. Now at this level, in the chimney shell, you have maximum bending moments. And at that place, you have to provide so many of these cutouts, which becomes a critical problem for the design of this chimney shell. That is this shell, sorry. So we will address that as to what we do for this, but it is a critical level to for the design. Bending moment maximum, thickness maximum, cutouts are maximum. At every about 40 meters, we provide platform wherein we should be able to walk from the periphery, where you have some arrangement, cutout, etc., to the platform, across all the flues, and back to a staircase here. Now just see, in this case, staircase can be inside. Why? Because each of the flues is separately insulated against the temperatures, which means a man can walk here. The temperature is about maximum 40 degrees or so here, which means that the insulation that we provide into the flue is, there are mathematical calculations for it. There's a metal inside and there's insulation outside, which is normally in the form of rock wool or glass wool. Glass wool is more expensive, rock wool is less expensive. Glass wool gives you a larger thermal cutoff. Rock wool gives a lesser thermal cutoff, but you design for it in such a way that the temperatures here theoretically are not more than about 45-50 degrees. Even that is high. And you have a staircase through which you go up 40 meter, 40 meter, 40 meter, like that. So at every 40 meters or so, we'll have this kind of a platform. Now, how we provide these metal flues? These metal flues are hung from top. So from every upper platform, about 40 meter long piece is hung. Then for the next platform, another piece is hung, which is also 40 meters approximately. So what is done is that this is a piece hanging from upper level. It hangs up to about 1.5 meters or 1 meter above the next platform level. From this platform, something is hanging and something is a little bit going up. Between the two, we provide something called expansion joint. Now, what is important here is this fellow should be able to take expansion and contraction between the upper flue and lower flue, obvious. Other thing is none of the hot air should be able to come out into the space that is inside, inside the chimney shell, but outside the flues. So for that, we provide a lot of these insulation materials here. It's expansion joint, material, bolster comprising glass felt, and so on. There are some intricate details of all this fixed with the GI boards, etc. And these things prevent the hot airs from coming out, and the temperature, which may be 100 degrees, 150 degrees for different power plants at different specifications, they should not come into the open space inside the shell. Yes, so just above the platform level, we also have a cutout here. As you remember, there are platforms here. From the platform, we should be able to stand on the platform and access this cutout. And this cutout is for the purpose of being able to see inside the flue when the boilers are stopped and be able to maintain the flues. So there is an access opening. So this what we see here is that access opening. This is a real thing, that is the mild steel flue. And these are the insulation materials, rock wool, I think in this case. And these are the cutouts, which are also covered with a cover. And this cover also has double layer of this insulation. So that insulation is over the cover and it overlaps with the other insulation with double the thickness to prevent, again, hot airs from coming out. Now let us see the design part of it. In a chimney shell, as Mr. Hegde also mentioned, the majority, the main design force is wind. But interestingly, wind has two components, two major components, let's call it. Along wind, that is in the direction of the wind, and a crosswind. What happens that when you have a along wind, that means the wind is acting like this. You get an obvious force in the particular direction in which the wind is acting. And chimney tends to move like this. It's a dynamic movement. Now you also have a crosswind. That means wind could be in the other direction. In which case chimney would move obviously in that direction because the now wind is in the opposite other direction, perpendicular direction. But in the process, what happens is that when the wind is trying to blow like this and blow like this, in fact, even due to the wind which is in this direction, you have chimney movement in the other direction also. Why? Because, as you notice somewhere, if you have any circular or any object and you blow the winds, there is some wind that is directly hitting the shell, which will be moving the shell in the direction of the wind. But there is some wind that passes through from the sides, and that causes a suction effect. And this suction dynamically varies in such a way that this chimney shell goes this way, then it becomes too much of displacement for the chimney, then it returns like this to the other direction, goes, comes, goes, and comes. In this whole process, and the fact that the wind is blowing like this, we develop these vortices. Vortices are low pressure zones like voids. And these vortices cause dynamic transverse effects on the chimney. The chimney being just a shell. For example, a chimney having a diameter of somewhere about 20 meters will have a thickness of not more than 500 millimeters normally. 500 millimeters, sorry, half a meter. So a chimney undergoes this kind of overlaying. Though on an exaggerated scale we have drawn, but this overlaying for which the chimney has to be checked also, the shell. The along wind, as we have in our code, there is a pressure coefficient, there is a coefficient of drag. Now this coefficient of drag, if the wind is hitting a wall, it is just 1, CD is 1. But when you have a circular shape, then CD reduces to 0.7, 0.8, depending on the shape of the shell in plan and its roughness on the surface and into the diameter. So that becomes a pressure wherein the basic pressure PZ is VZ, K1, K2, K3, K4, whatever we have in our IS 875 wind code. So this is static wind approach. In this static wind, you just take wind as a force, and you have all these factors that you apply, like diameter of the chimney, etc., and you get some value. But there's another part of it, that is dynamic method. In dynamic method, there is some gusts are created. So there is something called gust factor, G, capital G, and there's a fluctuating component and there's a static component. Basically, given the frequency of the chimney, natural frequency of the chimney of vibration, like in the case of earthquake, this force Fz, Fzm, and Fzf, they vary based on the time period. So there is a fluctuating component that depends on the time period, and eventually get a force which is different. And the first part, mean hourly wind, one is static wind, other is mean hourly wind. The static wind is designed for 3-second gust speed, whereas mean hourly wind design is done for mean hourly wind after and applying a factor of this gust. Sorry, I got mixed up between the two. Okay. Now you see something here. There is this cutout due to whatever reasons, and this forms an angle alpha. This alpha is taken into design while designing the chimney shell, and this has come because of the cutout, and that's where one of the key problem lies. The other problem with chimneys is that you make a chimney today within a distance of about 15 to 20 diameter, the base diameter of chimney. Somebody else comes and makes another chimney. The chimney starts experiencing interference forces. That means these are aerodynamic interference, wherein the wind flowing from other chimney towards your chimney causes dynamic effects, which are mostly transverse into your chimney. That means the aerodynamic interference is felt on the leeward side. So when you have to construct two chimneys, one now, even one in future, you'll have to design this chimney for the aerodynamic interference effects, and they can be very high at times. They can be even as much as 3 times, 4 times of the wind forces otherwise. So normally there's a regulation that if you're constructing a structure, you have to make sure that the effect of that structure is not felt by the nearby existing structures. Safely, I would say, if you keep the next chimney at least 500 meters away, there'll be no interference effect, because chimney diameter will be in the range of 25 meters at the base. But if you're yourself making 2 chimneys right now, right away, while conceptualizing, you will take the interference forces right away, and we are taking it. But make sure that nobody can bring in a chimney within that distance in future. Buffeting aerodynamics. Okay, so what happens here, the interference effect I was talking about, there were different provisions in IS code earlier, which have been now brought in line with ACI code, ACI 307 to be precise. Conceptually, it works something like, the shape of the diagram is somewhat similar to what we see SA by G diagram of the earthquake, but it's not SA by G, it is not earthquake. It is that spacing of 2 chimneys, given the diameter at 2/3 the height, sorry, not base, 2/3 the height, ratio of the distance between the chimneys at 2/3 height, at 2/3 height divided by the diameter of the chimneys at 2/3 height, that ratio, if it is more than certain value, very safely 20 times, there is no problem. Then you are in this zone, which you see flat zone here. But when it is about 3 to 4, that means the second chimney is very close, then you have the highest effects. It almost goes into resonance. But 3 to 4 is normally not happening. It does not happen. But anything around 5D, 6D, 10D will cause this kind of effects, which will reduce as the distance goes up. And these diagrams are typically meant for, the typical diagrams have been prepared for 1:50 taper in the chimney shell. Otherwise, it can be specific to any given taper of the chimney. So when we have these effects, which are aerodynamic interference, as I said, one of the concepts has been to provide something to deflect the winds. That means you provide some protrusions outside the chimney shell called strakes. And these protrusions, what you saw in the first or second picture, they are actually provided. And until ACI 307 came, or until our code was modified based on ACI 307, strakes were a solution to reduce, or rather to cut down, the transverse effects on account of interference. But somehow or the other, what changes have come about also, I will tell you all, that at that time in the old code, even distance up to 20D between the two chimneys used to be called effective for this purpose of interference. Now, based on ACI and present code that we have, this distance has come down to about 12-13D, which means if your distance is about 15D or 17-18D, there will be no interference effect. But if it is less than about 12-13, there will be interference effect. But they have eliminated the requirement of strakes for two reasons. One, that they have already relaxed something else that we talked about just now. Other is providing and maintaining these strakes was always a difficulty. These such strakes which are provided outside the concrete shell used to fall down. They were not equally durable. Their connections and so many things. And these strakes are made mostly in metal, mild steel. And these strakes, just to know the numbers or the size, is something like 1.8 meters projecting outside the shell. And some dimensions, there's a design for it. But what is projecting out cantilever is in the range of, say, 1.2 meter, 1.8 meters, which is a large size. Now, when you provide strakes, the drag coefficient CD, which was originally 0.8 for a circular chimney, it increases to about almost 1. The drag increases because something is protruding. This protruding part will give a larger longitudinal force, but transverse force is cut off. Now, let us say we have no nearby chimney. We only have our one chimney. One chimney will have longitudinal effects, that is a long wind response of the chimney. It will also have transverse effects because of the hollow space that is generated near the chimney and the low pressure zones which are generated in the chimney. Now, these things are controlled by the dynamics of the chimney. The force that is across wind, the transverse force, is controlled by the dynamic. That means that a natural time period of the chimney, which is the cantilever, of course, from the base. So for that, what we have to do is to find out a VCRI, that is critical wind speed at which transverse effects will be the maximum. Say your total wind speed is highest one is 50 km per second. Now there are formulae based on which we'll find out what is VCRI. That may be, let us say, 30 meters per second or 40 meters per second. Let's take an example. And that 40 meters per second, we will find that the transverse effects given the formulae are the highest. What we'll then do is assume that the wind is at 40 meters per second and not 50. Take the longitudinal effects also on that 40 basis, and transverse on the 40 basis will be the higher one. Add the two with SRSS and design the chimney shell. Now, some of these effects are better realized in a wind tunnel study as opposed to doing theoretical numbers. So many of the contracts tell you that, look, you use the code, but also you carry out wind tunnel study on the chimney for either interference or otherwise for a single chimney also. And whichever is higher, use that, or some say that you use only what you get in the experiment, blah, blah, blah. There are very many sort of explanations to these. So what we do is we make a scaled model, usually 1:200, in a material whose dynamic characteristics will be the same as that of chimney that we are talking about, actual chimney, at the location with the height and diameter, and also defining these obstructions nearby, which will reduce the wind forces. So they should also be put there and then wind applied on it. They can be flat chimneys also. You see some flat chimney here, where the heights are 70-80 meters or 100 meters, It may work well enough to make a flat chimney. Why taper it? Because tapering requires more efforts to construct. But when it's taller, 150 meters, 200 meters, 275 meter, you have to taper. There's one more model that is being prepared or has been prepared, which is in hilly terrain. So everything has been prepared here in the same way. In the particular plant, there are also cooling towers of some height, maybe 100 meters. There are chimneys, maybe 150 meters. So everything has to be modeled in the wind tunnel study. Yeah. So this is a location where the flue have to be entered, and how to detail this. Of course, here you're seeing only one, rather two, one behind. There can be more numbers. There can be 5 numbers. How to see that the shell is safe with the reduced area. But there are stress concentrations here. So one of the things that we have done is to carry out this kind of a finite element analysis, taking a small part of the chimney, giving certain boundary conditions at the bottom and top, and finding out the stresses around. But there are also methods, mathematical methods given in the code, which you can apply and find those stresses out above the opening, sides of the opening, bottom of the opening. But after having done that, you find out certain additional reinforcement around the cutout. Like this is a cutout. This is a case of, it's a drawing from the 5-flue chimney case. So here, we have this reinforcement, which is additional, and you see several layers of reinforcement. And there are, of course, several cutouts, 5 of them. So in any one direction of wind, 2 or 3 cutouts will be encountered in the tension zone, and 2 or 3 may be encountered in the compression zone. And concrete shell must be safe in tension and compression. In a case of a chimney, the checks are made both for compressive stress as well as tensile stress. So what is done is that this kind of extra reinforcement is provided peripherally. The side vertical reinforcement is fine, going up to about development length, anchorage length, LD, whatever. But the peripheral reinforcement, as per the code, has to go all around the chimney shell, whether you have 1 cutout or 2 cutouts or more cutouts. Maybe for 1 cutout, it may sound very over-conservative, but that's code norm. Coming to earthquake. This is a very famous diagram. We talk of single degree vibration, 2-degree vibration, 3rd-degree vibration mode of a chimney, which is a cantilever fixed at the base. The SABIG diagram is all, I'm sure, very well known to everybody, so I need not elaborate. For concrete chimneys, we take a damping factor of 5%. For different substrata, there are different acceleration diagrams. And these diagrams have also changed from time to time. So let us not argue what diagram is correct, if it's right or wrong. It has gone on changing from time to time, especially this part of the diagram. It was flat sometime, it dropped sometime, not something else, so on and so forth. But idea is that we have this kind of diaphragm qualitatively, which means larger the time period of a chimney, lesser the SA by E, therefore lesser the force, and lesser the time period, higher the SA by G, and therefore higher the force, highest being 2.5. Earthquake is normally not critical for a chimney design, especially in the lower zone, in the lower heights, say at foundation and maybe 100 meters in a case of 275 meter. But customarily, we have to keep checking at various heights. And you find that off and on, somewhere where the wind effect has reduced, earthquake effect still is high or whatever number. The earthquake governs at some of the heights above half of the height of chimney usually, but a lot depends on the dynamic characteristics of the chimney in terms of its diameter, in terms of its height, thicknesses, and so on. And this is a standard formula that we have from IS 1893. There's something interesting about wind and earthquake, it's a general thing. It's not only to do with chimneys. If a structure is more flexible, it attracts lesser earthquake because time period increases. But at the same time, the along wind effect increases, means earthquake reduces, wind increases. And of course, the second part we saw, the critical wind speed business, where highest wind may not be critical, it may be a lesser speed, which is VCRI. Now for the design of temperature part, thermal of the chimney shell. What we see on the right side here is a chimney shell. And we have an air gap. We have insulation. The pink one is insulation, and we have lining, say brick lining or metal lining, whatever. The temperature starts dropping like this. You have a temperature T1, T0. T0, first of all, drops at the surface of the lining itself because of the flow of the air. So that flow reduces the temperature. Then it reduces quite drastically, little bit through the thickness of the metal. Thereafter, it reduces drastically over the insulation that you have, the pink one in color. Then there's some reduction on account of the air gap. This air gap is the one where air is passing from bottom to top and vice versa. And then there's also some reduction in the chimney shell itself. Then another reduction of temperature as we come outside of the shell is air blowing or air passage, which is outside the concrete shell. So likewise, you start from T0, you get T6. But what you have to design the chimney shell for is T4 to T5. I mean, we have designed chimneys wherein the thermal plant temperature is 100 degrees, 140 degrees, 180 degrees also. But for refineries, this T0 can even be as much as 700 degrees. But I don't think we have designed, maybe we have designed one or two of them for 700. Then the type of insulation also will change. Type of brick will also change. It can withstand these temperatures or metal, whatever there is for the flue. Now, since it's a circular slab, a circular shell, we have reinforcement in the inner layer and also in the outer layer. Outer layer is not an issue, but the inner layer reinforcement has a tendency that under tension it may try to straighten out. And once it straightens out, it will come out of the concrete cover. So to arrest that, we provide transverse reinforcement, especially when the chimney diameter is small. This is a common requirement, not only here, but any curved structure will have this. We also have it in pre-stressed concrete in some way. So it's a common thing. Now, lighting and painting. At the top of the chimney, since it's a tall structure above 100 meters, we provide aviation warning lights at every 45-meter height interval so that any aircrafts, etc., can see this and escape. Number and arrangement of lights shall be such that obstruction is indicated from every angle. That means from every angle, you're able to see that there's a light blinking or stable, whatever. Shell is painted with alternate bands of red and white that we saw. Towards the top, the shell has to be painted with acid and heat resistant paint. So for a better protection, because acid concentrations are more towards the top. We also provide lighting protection because chimney being the tallest nearby objective, the lightning will first strike the chimney. So we provide pointed vertical rods projecting 0.75 meter above the topmost point. Function is to divert the lightning, discharge it to itself, which might otherwise strike the structure. Material is lead covered copper rods are provided top to bottom, and at the bottommost point, adequately designed this lighting arrestor pit is provided. And down conductor should follow the most direct path available to the earth. That means they're just taken straight from top to bottom, and earthing is provided there at the bottom, which is designed for certain voltages. Now we come to the construction. Now, constructing a chimney of that height, you cannot imagine providing a shuttering top to bottom and supporting the shuttering. So what is done is slip forming. In the slip forming, as we start constructing, we erect this kind of a formwork which can keep on climbing and keep on, shuttering and formwork and keep on climbing, and you can keep on pouring concrete. Concrete hardens, you move up, concrete hardens, you move up, something like this. In this, if you notice, we have a shell that is under construction here. In this shell, we provide PVC or some pipe. Inside the pipe, we place a metal rod called jack rod, which is normally 32 millimeter bar. Now, this jack rod plays a very important function, this jack rod. There's a hydraulic jack which is placed here, central hole jack. There is a lower yoke beam which is here. There is a screw for shell thickness adjustment. There is yoke lag which is here. There are jacks at the bottom here, pink ones, to reduce or increase the perimeter or the diameter. This, of course, is jack rod, as I already said. This is a hydraulic jack, as I said. This is a pipe sleeve. This is a working deck where people have to stand and watch and maybe do this needle vibration. And this is a hanging scaffold where you can get the material and work from there. And you have a huge, long, tall hose. Through the hose, you discharge the concrete. Now here, there's no mathematics. There's nothing written down in the code or anywhere. At what speed you should go up. If you go very fast, then this jack rod will shake because of this concrete which is below has not hardened sufficiently. If you go slow, then concrete would set and your next pour will be having a cold joint. So it's a practice through which people find out at what speed they should move, and usually it is 150 millimeters to 300 millimeters per hour. At this speed, when you move, concrete is rightly stiff, not hard, but rightly stiff to hold the jack rod, to hold the platform. Therefore, every platform that you see here, the entire thing is on the jack rod. And also at the same time, make sure that the concrete has not set. So that is some speed which comes from the experience of the workman. And also given the temperatures, given the winds and all that, they decide at what speed they should move up and keep on pouring. The advantage of slip forming, other advantage is that you get a continuous concrete without a construction joint. Otherwise, you'll have, if you do jump form and all, you have construction joints every now and then. If you do any other form for this height, it'll have construction joint. But slip form does not have construction joints. It's a continuous concrete. Of course, accidentally, due to any failures of jack or any other thing, at times a concrete is stopped at certain levels, accidentally. Then they have to make up the construction joint, remove the lattice, remove the loose aggregates, and put this maybe any kind of a construction joint joining agent, and then start pouring again. So this is a real picture of a thing, which is something like this: lower platform, upper platform, and it looks quite complex to understand this. It was easier on the diagram that I gave. This is when the slip forming was just about to start. So lower working deck, upper working deck, likewise, a lot of these things. Now you see these trusses. Now these trusses are provided inward to outward or radially because the diameter of the chimney, which at the bottom is 26 meters in this particular case, has to reduce to 16 meters at the top. So that reduction of the thing which will happen in the shell is taken by these trusses, which are transversely oriented, and they will keep on going up. And as you keep on going up, you will go on reducing some pieces of this transverse or radial truss. So all the same things: hanging scaffold, working deck, jacks to reduce the perimeter we discussed in the diagram, then hydraulic jacks to lift the assembly. Now, how do you lift also is a question. Jack rod, which is somewhere here, hardly visible. Yoke leg. There is something called rubber elephant trunk. That is a concreting part of it. Hopper through which you pour the concrete so that it doesn't have splitting of the aggregates. So you do all this. Now, next and last, I think, slide of mine is that how do you raise the 275-meter tall metallic flue? Now, as I already said, that the flues and platforms, they are in 40-meter segments. Now, this flue is typically hung like this. If it's a short chimney of 50-60 meters, you start stacking the pieces of whatever length you choose from bottom and take them up. But typically you have an arrangement where you suspend everything. So you first of all take the very first piece, take it up, connect it. Then you take piece number 2 from the bottom, take it up, connect it. Then piece number 3, take it up, connect it. So likewise, you go on taking all these pieces up and keep on joining to make a continuous flue with the expansion compensator and all those things. But as I said, each in the tall chimney, each of the 40-meter pieces finally suspended, and between the two pieces, between any two adjoining pieces, there is expansion compensator. So for lifting this metallic thing, which may be weighing 200, 300 tons, each of the flues, we use this kind of a strand jack, wherein we have a jack with a central hole. We have 2 other jacks here holding this cross beam, like you may have seen in the jack down sinking of wells. These strand jacks do the job of lifting the flue. So that's it from my side for the moment. Thank you.
Thank you, Vinay, for that excellent presentation on chimneys. In fact, I didn't know that you have done so many design of so many chimneys in our life. I was always under the impression that you are a bridge engineer, but it's very good to know that the extensive work which has been done by you on the chimneys. And before taking up the very, very interesting questions which I see in the question and answer bank, and I just want to bring to the notice of all the participants, since this brick lining chimneys as well as the flue lining chimneys, the advancement which has taken since then is the FGD chimneys, as well as what they call it is the elimination of this brick lining as well as the flue liners with the borosilicate liners. Basically those liners are typically stuck to the windshield itself or the concrete shell itself. That eliminates all the requirement of the platforms. So many complicated platforms you might have seen over there. And with that kind of arrangement, people have gone up to the height of 200 meter, with the borosilicate lining, or what they call it is a new chimney design. These days, that's the word which they are using. The elimination of the brick lining as well as the flue lining, and also the internal platforms. Normally, these internal platforms, earlier days in the initial stages of the chimneys used to be of the concrete platforms, concrete beams, as well as the concrete slabs. Typically, these platforms used to be there at around 40 meters center to center, as Mr. Vinay also showed that, and it used to be very difficult to construct this concrete beams as well as the concrete slabs at a different height. And that is why later it was changed over to this steel composite sort of a platform. The slab is RCC slab is there with the steel girders. Also, if you really look at this, the chimneys, not the single flue chimneys. If you go look at the multi-flue chimneys, which Vinay showed, in multi-flue chimneys, the another facet of the feature is the staircase. Normally, we have the steel staircase inside the chimneys. I think that itself, designing of that, planning of that, and you'll have to have from one platform to another, 275 meter up to that height, people has to climb that. That has to be there, and you will have to have a lid, openable lift from the platform, so that from the staircase, the people have to enter. You will have to. That is also a special design. I still remember that lid design itself is a very special design used to be there. Apart from that, also we have pulleys at the outside, which is hung from the bracket from the top of the Vinay, if I'm not mistaken, it has to be there for the maintenance of this chimneys. That from that pulleys, normally the people will be coming on the surface of that. Also, we have that what we call it as a lift, which goes on the surface of the chimney, outside surface of the chimney up to the top. And also when you have a tall chimneys like 275-meter windshield, it becomes necessary for us to have at the bottom up to the height of, say, for example, 60, 70 meter, it will be having a conical taper, basically. And the conical taper has to be decided on the basis of your jump form requirement. Otherwise, if it's very steep, that the conical bottom cannot be constructed. And these are some of the subtleties. But going forward, what I see is because of the FGD in the sense fuel gas desulfurization, that means whatever the sulfur oxide which is there in the pollutant emission, that sulfur will be reduced to the level of by 90%. So by reducing the sulfur by 90% by mechanism, what happens is the height of the chimney becomes lesser. That is why it is called FGD chimneys. Normally, where you require the 275-meter chimney, if you're going for the FGD chimney, it may be around 150 meter or 120 meter. So that we will be having an FGD chimneys which is less in height compared to that of the earlier requirement of 275 meter. Then the interference effect, what Mr. Vinay showed, we have got already a 275-meter chimney and another chimney is going to come side by it, say for example 150 meter. Along the effect, I think if you study in the wind tunnel testings, those effects, the crosswind oscillations which is coming because of the interference effect on the smaller chimneys incidentally is going to be critical. That's what nowadays understanding is, but that is not mentioned in any of the codes yet. It has to yet come. So there are, with the advancement of the technologies, there are new problems, and also the height of the chimneys is going to be reduced. And also the FGD chimneys, if it is not a borosilicate lining, if it has got a steel liner or a brick liner, as you showed it, if the FGD chimneys, the platform requirement is, causes the problem during the construction. I think all these problems are there. I see those questions are being asked. I think we will take up the questions if Aloka, if you want to say something as a panelist, I think you can say something, and after that I'll be taking the questions. Very, very interesting questions are there in the question and answer box.
Thank you. I just want to say that it was an excellent, lucid presentation, very, very informative. I have never designed any chimney, but I have learned a lot today from Vinay. Excellent presentation, the way he has explained all aspects. Very nice. I only have two very simple questions just for curiosity. One, when do we provide steel chimney? Because I have heard also that, concrete, but there are steel chimneys also very popular. So is it the cost factor only, or is there any specific areas where we provide steel chimney? And the second, I was just wondering, because you showed some cross section with a stress level which is linear. Is it that we are still designing chimneys based on working stress approach, or we have moved to limit state?
Yeah.
Thank you.
Now, your question is actually pertinent, and I was expecting somebody else also would ask the same question. First of all, going to the first one, why metal? See, usually single flue chimneys are short. They are in the range of 100 meters. Now, in the 100 to 120 meters, and if it's a single flue chimney, usual pattern is to provide a brick lining inside. But when the height increases, then the flue weight also increases a lot. And single flue chimneys beyond 120 meter or so, or maybe 150 maximum we have designed, are more or less extinct. Now you only have these very tall chimneys. In the tall chimneys, it works better to have multi-flues if you have number of boilers or number of machines to serve. the flues becoming too heavy if you make it in brick. Though I'll give you an example in that Sika chimney for a height of 150 meters, we provided brick lining, but that was the requirement of the client. And it is obviously cheaper. So at every some height of 20, 25 meters, there were platforms and taking the brick flue. But when we look at 275 meters, the weight will be enormous. That is one problem. Secondly, brick cannot stand a height of 40 meters. It will have to be much lesser, maybe 20 meters, maybe 15 meters. So that is also another reason that how to create so many platforms. Already Mr. Hegde said that creating a platform is a difficulty in construction. But one thing I wanted to correct one thing, that in all the chimneys that we have designed, the multi-flue chimneys, the platform is in steel only steel, no composite. It is as a grated platform, grating. So that is one of the things that why these have to be in metal. Metal has a problem that it has corrosion and it has all those things. You have to protect it through the coating and also redo coatings later on, for which you keep an opening for a person to go out. And your other thing about working stress, you got it very right. This is a older sort of pattern. Now these new codes have changed to limit state method. I wish I'll probably try and modify in my next presentation. Here, of course, I have touched upon only the method, but you have very correctly caught that point that nowadays the designs are limit state method designs.
Thank you.
I think, Vinay, the question which has been asked by Alok Bhaumik is, it's not the steel liner versus brick liner. He was asking about normally up to 100 meter, we go for the industrial stacks, what they call it as a steel chimney itself. Even the windshield also is that of the steel.
Right.
That is because it's easy to construct, basically. Like it's easy to construct, and if it's very tall, you cannot erect that tall steel in modules. Normally it is done in modules and put on one top of the other. That's how the construction of the steel stacks are done. But if it's beyond a certain height, it becomes very expensive. Steel the stacks becomes expensive, and also the construction may not be that easy. That is the reason sometimes we go for the industrial stacks called the steel stacks, and sometimes we go for the RCC windshield chimney. I think that should answer your question, Alok, basically.
Yeah, thank you.
Of course,
in case of metal chimneys, we also have to, if a height is more than 20-30 meters, provide those guy ropes.
Guy ropes, yes.
For anchoring it. We have done it, I think, once about 35 years ago.
So we have many questions here, and I'll be taking all the questions one by one. And there's a question from Ravindra Shah. Basically, it's related to the FGDs. What I see is, it is observed that the reinforcement details of the extra bars to be provided at opening shows hidden beam inside the shell wall. The beam reinforcement also includes closed turrets, which is for conventional construction, where each of the rebar fixing, shuttering, and concreting is carried out one activity at a time. In slip forming, the shuttering is already in position, and rebar fixing and concreting are to be carried out simultaneously. The details of the extra rebars are for conventional construction and totally unsuitable for slip forming. Invariably, the slip form operation come to a standstill. This is what the observation of Mr. Shah. He goes on to say that platform design shows beams resting on walls. This requires erection of platforms to be done one beam at a time and time consuming. All over the world, the platforms, including the checkered plates, are assembled at a grade level and lifted using the strand jacks. Therefore, design needs to be modified so that the construction is simpler and faster. Nowadays, in FGD chimneys, it is observed. I think these are some of the statement from Mr. Shah. I think it's
valid statements, I must say.
Statements. And of course, the designer has to take into consideration the constructability aspects, basically. And I also told in my initial remarks, the earlier days in the chimneys, we used to have the concrete platform. And when the concrete platform were designed, even the precast beams, which were cast at the bottom, or the precast beam which were done, were pulled up, and it was put on top of that. It depends upon the designer and the constructor, and taking the constructability into account, I think the construction sequence have to be planned. Accordingly, the design has to be done. And certainly these days, nobody is going for, as Vinay said, for the concrete beams. Everybody is going for the steel beams. And even the platforms are of that of steel gratings. It's not RCC slab, but some of the contracts specify you'll have to have the RCC platform. Then you don't have an alternative but to go for the RCC platform. That's a good observation from Mr. Ravindra Shah over here. Mr. Jairam Kurup is asking, what is the maximum height of a chimney constructed in India so far, and where is it located? And the owner of the chimney, designer, consultant, constructor. In India, the maximum height of the multi-flue chimney and also the single flue chimney is around 275 meters, and there are numerous. It is not one designer or one contractor. Many people have designed 275-meter tall chimneys with the multi-flue as well as the brick single flue, and both with the option of the brick lining as well as the steel lining option. So it is not one consultant or one designer or one contractor which has been done. Abhijit Onkas suggests that the chimneys are not much subject to seismic forces due to very low time period. Abhijit, I think if you are hearing, listen to me, the way the seismic code is changing, it may not be the case anymore. We prepare to design the chimneys, and the seismic also may become critical for some of the chimneys, especially where seismic zone 5 is there. In my opinion, it may become. And
if I may add, you see, there is a problem of liquefaction, which has not, whether it is tall or short. Yeah, I mean, when you say seismic, the liquefaction has to be included, so which may change your type of foundation altogether.
Right.
Only thing is when it becomes critical, it because the seismic governs or seismic doesn't govern. It is very important to do this capacity design for the chimneys. But the chimney is a cantilever structure. How are you going to do the ductile detailing for chimneys has to be really worked out. I have not come across a case where a chimney, in case of the chimneys, the ductile detailing at the bottom is done yet. And irrespective whether the wind is governing or the seismic is governing, when a design is done for the seismic condition, the ductile detailing for zone 4 to zone 5 has to be done. And I have not come across a chimney where the ductile detailing is done, especially at the bottom of the chimney yet.
Shell, I think.
Yeah.
Not even this, what do you call it, silos.
Silos. But I think the way the seismic forces, seismic demand is increasing, I think all the structures start governing, governed by the seismic design. When it is governed by the seismic design, I think we'll have to come out with the ways of doing the ductile detailing, even for the stacks, chimneys, and this kind of structure. That's what I feel.
Yeah.
I think that. So, Abhijit, tighten your seatbelt and be prepared for designing your chimneys also for the seismic forces in the future.
But one thing, just as a matter of information, the vertical loads in a chimney shell are very small compared to the concrete area that we have, the cross-section area we have.
Yeah.
As a result, it's a case of vertical load being less than 0.1 P, 0.1 A, but 1 P, whatever that thing. So it's that case. Okay, you're right.
Mukund Chai is asking, what is the expected life of a lifespan of chimneys? I think it's 100 years, right? It's designed for nowadays for 100 years. The design life is 100 years. Service life is 100 years, but I don't know how many chimneys
will actually survive. But the wind we take is for 100 years.
Yes, 100-year return period has been
But
taken.
what about the durability considerations? Is it as per IS 456 or
IS 456? It is basically
normal. Yeah, nothing is special.
Now, Ravindra Shah is again come back and asked about this FGD chimneys. I think this is a problem everybody is facing actually in case of the FGD chimneys. FGD chimneys, which has a liner, either the brick liner or a steel liner, and also requires a platform. This sort of problem is normally faced. FGD chimneys there with the borosilicate lining, which is stuck to then the platform is not there, only the bottom platform is required. This sort of problem doesn't come. But just to read out the problem which he has raised is, nowadays in FGD chimneys, it is observed that a support platform is provided below the inlet duct also. This platform cannot be erected before along with the other platform beams and requires lifting the inlet duct above the resting level and keep it suspended till the lower support platform can be completed. Just to add to that, normally this, in case of the FGD chimneys, what we find is the bottommost platform, which is below the duct, is at a very higher level. Normally, earlier days, it used to be at around like 15 to 20 meter, the inlet duct used to be there. But I think in the FGD ducts, for some reason, it is going much up. That's why these problems are coming. With flue erected by that time, erection of the inlet duct platform becomes cumbersome and time consuming. We are erecting partial platform between the main beams using strand wires, which requires main beams to be lifted and moved away for the partial assembled platform to be erected. Again, the design is totally unsuitable and needs to change. Again, to answer your question, Mr. Shah, basically, I think the designer and the constructor has to work together to work out a constructability solution. And also, one can examine whether the bottommost platform can be supported from the bottom, or it can be supported by the bracket, sidewise, which is stuck to the shell, and temporary, some sort of a shuttering arrangement which is supported by the bracket can be done, and it can be done. I think this problem can be overcome if the constructor as well as the designer works together, and also the sequence of construction is well planned. I think it's possible to overcome. But certainly, I recognize the problem, and this problem has been faced by many of the contractors, what I say. Ravindra Shah goes on to ask, the design drawing shows a starter of around 200 mm height for shell wall to facilitate assembly of slipform system. The design drawing shows a starter of around, okay. This is really done, not needed, and technically is very weak zone for the chimney wall. The slipform system assembly does not require the starter and can be assembled directly on top of the foundation. Designers have been justifying this starter for assembly of the slipform platform. The starter should be done away with. Do you have any observation on this question, Vinay?
Yes, see, I do not know the starter business. Yes, starter is normally required for making any shell, any column, any vertical element. But whatever I have seen among the chimney that I showed here, about, let's say the foundation top is about 3 or 4 meters below the ground, or 1 meter below the ground, as the case may be. Another about 5 to 6 meters they have built up above and the normal shuttering before starting the slip forming process.
Yeah.
I don't know what your experience is, but this is what I have seen.
Yes, absolutely. In fact, normally, as you rightly said, the minimum requirement from the grade level to the top of the shell, in the top of the foundation or the raft, is around, minimum requirement is around 1 meter for provision of utilities and those sort of things which has to be provided at that. I think it has been provided. So at least 1 meter height before the erection of the slip form, it is normally constructed. More than that also is constructed in many of the cases, as you rightly said.
Right.
Starter is not require maybe the requirement of the slip form, but it requires, so that the slip form rods, what Mr. Vinay has said, that that the rods have to be there inside the concrete, that rods have to be there, jack rods. On top of the jack rods is the entire slip form assembly is resting when the slip form is being done, and perhaps some sort of a starter or some shell at the bottom has to be, windshield has to be constructed before the slip form is started.
Right.
That may be the requirement.
That's right.
It's not that it is impossible to do away with that, but Well, you'll have to put that rod on top, exactly on the shell and on the foundation itself and all. But I think it may be, may not be required to do it. You construct that shell up to the certain height, and after constructing the shell up to the certain height, you can always start the slip forming. There should not be an issue on that.
The stability of the rod is by the concrete around it. So that concrete is part of the shell.
I have another question from Dr. Suresh Kumar Nair, and obviously it must be on the wind loading, what I says. And he says that the Vinay, strakes cannot reduce the interference issues. Strakes are primarily provided to reduce the crosswind across the wind forces by distributing the vortices shed from the same chimney, not from the nearby chimney. That's right. So the solution is, of course, as you said, increase the distance between them or position the chimney in a non-dominant wind direction by studying the wind climate or add a damper. That's what he says. In fact, I just want to bring into the notice of all the audience here. The strakes is the invention of the Indian scientist or Indian. It's been done in IISc, Indian Institute,
IISc, yes.
Bangalore. And in fact, when the strake provision was to be removed from the code, I hope Mr. Abhijit Onkar is listening. I was not in favor of it, only from the emotional point of view. It was some sort of an invention from the Indian diaspora, in the sense Indian scientist from the Indian Institution of Science, on the basis of experiments which has been conducted there in the wind tunnel testing for the different configuration. But somehow in the latest code of ours, the chimney code, the strakes have been done away with. And how it can be done away with, I think Mr. Suresh Kumar has explained here. Dr. Suresh Kumar has explained here by increasing the distance between the chimneys, and that's also the non-dominant wind direction by studying the wind climate. I think by placing those chimneys in that direction, I think we can do away with. But I would have preferred to sort of suppress the crosswind oscillations, the provision of the strakes. I think that would have made our chimney design more economical in my view. But I think we have done, unfortunately, we have done away with the provision of the strake in our
right. Right.
Dr. Suresh Kumar goes on to add, the current situation of having more less height side FGDs near to an existing tall chimney is an interesting one. The interference effect of low height or a side FGD on existing chimneys are less. But the effect is large side existing chimney on a small side FGD. This is what I was also saying. Small side FGDs are very serious. We do see that the wind loading go up significantly. Please note that this is not currently accounted in either ACI or any other codes. And also in the interference effect, not only increase across the wind load, but also along the wind load. That is very surprising to me. Across the wind increasing is understandable, but along the wind is also increasing. I think there's a case for Dr. Suresh Kumar to come out with a paper so that we can include this in our codes. How can we do that? I think we'll have to find out. Dr. Suresh Kumar, if you are listening, I think please come out with your, we might have done so many wind tunnel testing on so many FGD chimneys which are taller, which are shorter than the existing chimneys side by. I think you might have come to this conclusion. I think you should come out with some recommendation as to how to overcome this. And he said that
only that he gets more business into carrying out wind tunnel studies.
I understand he's already writing. I'm looking forward to his paper on this. It's a very interesting observation, in fact,
right,
by Dr. Suresh Kumar. And Mukund Jail is asking, instead of cast sensitive concrete, can we use precast segments to construct chimney wall? I think, in fact, using the similar principle of the design of the chimneys, many other structures have been designed and constructed. For example, drilling tower is another, it's a same chimney principle, chimney codes are used for doing that. Also TV towers, like the TV towers earlier used to be there. Nowadays, I don't think the TV towers are going to be there anymore. Earlier used to be very tall TV towers used to be there that used to be designed using the principle of chimneys. And lately this, the wind, like the wind energy, that wind towers, basically that's a tall towers. There, when you are doing this wind towers, it's a circular tower. It's a tall, some sort of a shaft, similar to that of chimney. There, I think its height is not much, around 70 to 80 meter or 90 meter. There, I think the precast segments are prepared and it's vertically pre-stressed, after having erected that the vertically pre-stressed. But I haven't come across a case where chimneys, especially the tall chimneys, are done in a precast segmental way and vertically pre-stressed. I have not come across a case. But it is done for a similar structures, like, as I said, for the wind towers, where this one is there.
But there are pre-stressed silos where you put circumferential pre-stressing in wide large diameter silos.
No, the question is whether it can be done precast.
But precast.
Precast, if it has to be done, it has to be done vertically, and it has to be pre-stressed, like piers. Sometimes precast piers we do it, and we vertically pre-stress it. That can be done. That has been done for the wind towers. For production of the wind energy, we normally have wind towers that's around 70 to 80 meter height. I think there it is done, but I don't recall a case where for chimney precast construction is used.
Correct.
Yeah. Which are the specialized agencies for construction of the chimneys? Ravindra Shah has already answered that. Begging India Limited, one such agency. There are many. In fact, I think chimney construction is done by NBCC, and chimney construction is done by Paharpur Cooling Towers company also, and Gammon Engineers and Contracting Private Limited also. Gammon has been doing chimneys. In fact, L&T also has been doing chimneys, and there are so many. Earlier, the Simplex used to do it. I do not know whether Simplex is doing these days. So there are so many number of companies are there, contractors are there who can take up the design as well as the construction of the chimneys.
Gannon, Dunkerley, Slipco.
Yeah, many of them are there.
Yeah.
Mukund Jail is asking again, what is the maintenance schedule of a chimney? I think I don't know much about it. I think Mr. Vinay, would you like to give some?
Well, it has so far been only need-based, like in the case of bridges. I mean, highway bridges, I would say, not railway bridges. Only that.
Hegde sir, if I just can add in the question, is there any provision kept for inspection and maintenance inside the chimney?
You see, normally this, thermal power plants as well as other power plants, which has been having the chimneys, they have a maintenance schedule. And for the purpose of the maintenance of the chimneys also, the shutdown is there. During the shutdown, we make the provision for going up the chimneys into the different platform. We have got a staircase, and also from the outside, if the requirement of the painting is there, for the painting, we'll put the pulleys at the top, pulley arrangement, temporary pulley arrangement, through which also there is a lift which goes on the surface of the chimneys. All these provisions are made. But the maintenance, the regime is being done by the owners, basically that, thermal power plants or wherever the chimneys are there. So as a designer and also as a contractors, perhaps we would not be, the right answer should come from the owners here, basically how the chimneys are maintained.
No, but if you want to have a durable chimney,
yes,
and you are saying the design life 100 years,
yes,
then it would necessitate some requirement from the designers also to have some maintenance schedule, I mean, as we do for other structures as well.
Ideally, it should be the case, but as Mr. Hegde also said just now, the power plant people do this inspection from the power plant point of view, which means they go up, inspect the flues. And when there are problems with the flues, they say, okay, rectify it or whatever you do. In the process, incidentally, while being on the platform, they may see something in the concrete, something is happening, or the insulation. Otherwise, there's no codified sort of stuff to say that you have to inspect and all that. As like in our bridges, where do we have that inspection and maintenance frequency defined? Very much the same way, honestly. It should be there, very correct.
Yeah, another question is from Mr. Joel is, are fans provided inside the chimney shaft to force out the fumes? Yes, fans are not provided inside the chimney shaft, but I think it's near the boiler where the, like the emission of the pollutant, like what I said, the sulfur oxide or the nitric oxides are there. It has been thrown out. It has been pushed out from there, but not inside the chimney shaft. We do not provide any. Am I right, Vinay? That
yes, absolutely. No.
Then Mr. Mukil Joel has again asked, can two adjacent chimneys be braced together for structural safety?
Bridge together.
Braced means the sense laterally supported.
Sure.
Normally it is not done. Normally it is not done. Such a tall structure and normally it is the spacing between the two chimneys are quite far to brace each other. It's not so closer that it is just side by side and it can be braced. I don't think it is. I have not come across a chimney where two chimneys are braced together.
You see, first of all, I'll just elaborate a bit whatever you said. Even the chimneys are never as close that you can provide a bracing. They are not like in a distance. Supposing you have a 25-meter diameter chimney. The chimneys are not even in 3D distance. They are in the range of 10D, 15D, 20D and all that. You cannot imagine a bracing for a width of 100 meters from chimney to chimney, number one, or other 150 or 200 meters. Second thing is, due to the dynamic, or what do you call it, the deflections, to avoid interference into the shell effect of it, on account of the deflections and making them free, even the platforms are not connected to the shell. They are also supported on some bearings or the other things over the corbels, brackets, or creating a cutout in the shell and placing it in the recess in the shell inside. Even they are not connected. Lever side bracings.
Yeah, that's true. And the next question is from Mitra C. Any design documents, worked out example available regarding the design of the concrete chimneys? As I recall, there's a very, very famous book of tall chimneys of design and construction by S.N. Manohar.
Yes.
That is considered to be the Bible, especially in India, for designing of the chimneys. But only thing is now a little bit, like the design methods are the same, like he has given a lot of examples about how to design the chimney foundations, whether it's an annular foundation, a raft foundation. And also he has given with the different openings, when you have got a different openings, how to work out the circumferential steel which is required. A fantastic book. Only thing is the design is now, as per the new code, we have to do as per the limit state. That particular book is based on the working stress method at that particular point of time. But the principles of the design can be very well understood by that book. I think it can be used as a Bible for the design of the chimneys, in my opinion. Would you like to add anything on that, Mr. Vinay?
Yes, I met Mr. S.N. Manohar some 7-8 years ago in Pune. I asked him, sir, what are you doing something beyond? He said, I'm retiring from this book. But anyway, the point is that if you read this book, lots of concepts of the design are made very clear in your minds. But after that, you have to apply your engineering, go as per the new course, as you said about working limit state and all that, and develop your own method. There's no standard, even software. I mean, all of our softwares are Excel-based softwares to design the chimney. There's nothing very standardized that you can say, okay, let me buy so-and-so XYZ software and things like that. So all this is really based on the engineering that you learn from this book, then apply your engineering for the structural design and then use it. There is no end-to-end example of a
Yeah.
chimney
Yeah,
design.
I remember having purchased this book way back in, early 90s when I was doing my post-graduation in IIT Delhi, and I had one course on, industrial structure. So,
Yes.
and I found that book to be excellent.
Yes, very good book.
Tall
Yes.
Chimneys by S.N. Manohar.
Yes,
Right.
Chimneys by Sen Manohar. And
Certain things may have become outdated. That's it. Like materials.
so for example, the FGD chimneys he has not addressed, and like also perhaps he has not addressed the steel liner at that particular point of time. Steel liners also were not in use much. Perhaps he may not have addressed, but I think the principles of the design, especially the windshield or a shell design, chimney shell design, and it's very, very well explained. In fact, in that book, yeah.
Second, a lot of formulae for various things like cutout is there and temperature and this and that are very well covered in the old code IS 4998 1975.
That's right. That's right. Yeah.
I don't know whether they brought it all into the new code. I don't think so, but they're very well covered there.
And Mr. Iyer comments that recommendation to perform buckling analysis of the chimney in case of large openings, considerable reduction in the cross-sectional stiffness needs to be introduced in the chimney code to give the user an insight if we encounter such a situation. This is to provide an optimized thickening solution around the opening. I think it's a good suggestion by
Point well taken. But what we do, I will tell you. We provide without any design a corbel at the bottom. We extend it as a sill and jam top to all four sides to locally strengthen through these lips, but without any design. About 30 to 50 centimeters all around.
And also see that the one is the local design. Another is also normally there is a restriction on the angle, subtending angle, which is forming the duct opening.
Yes.
And by provision of this subtending angle at that particular location, I think that is taken care of with the additional detailing, proper detailing around the shell opening. I think perhaps this buckling issue has been taken care of indirectly, may not be directly, but there's no harm in conducting this buckling analysis when you've got a large opening like this.
Yes, there are some cases of large openings, and especially when the opening is wide horizontally, it creates a bigger problem to the chimney design.
And Mr. Joel, I think he's not tired of asking questions. He's continuously, that's very exciting for us also to hear the questions from him. What are the codes for design of construction of chimneys? I think IS 4998, I think
Yes.
IS 499. This chimney code has been recently revised. And Mr. Joel, for your information, one of the authors of the chimney code reviser, Mr. Abhijit Onkar is also among us as a participant today. It's good to see him, and I think that is there. It's been recently revised. Major changes, basically the wind load and also the switch over to the limit state design from the working state design. That is the major change in the chimney code design. And what is the height of the tallest chimney in the world? In fact, I remember that Dr. George Slice has proposed 1 kilometer chimney, for the solar energy production. I think he had been talking about it, but I don't think it has seen the light of the day. And he had designed 1 kilometer chimney, and for the purpose of generation of solar energy, basically, that he had done it. Apart from that, I think it must be the 275 meter, must be the tallest chimneys in the world. There could be many. But
only the TV tower in Mumbai, which is 300 meters tall, or very old TV tower.
Yes.
Chimneys are only 275 because the pollution norms don't demand more than this as of date.
It looks like, yes. Now, a response reduction has been reduced. Abhijit Onkar is saying in the revised code, response reduction has been reduced. This is due to the lack of redundancy, he says, and also he says there is only one record of chimney collapse in the Turkish Izmit earthquake. That's what he says. I
Hmm.
could be there, but Vijit, I again repeat, be prepared to design the chimneys which is governed by the seismic demands. And chimneys cannot have ductile detailing since they are simple cantilevers. That's what I understand that, that once the start governing it, I'm sure people will start asking for it. That's what my feeling is. Let us see. I hope. I also am of the opinion, since it's a cantilever, ductile detailing may not be required. But let's see. Let's see. Joel again asks, is there any design software to design a chimney? Normally, chimney is, if you go through the course, and it is code is so very well written that you can make a program yourself in the Excel or any other language. Earlier, when we used to do the design of the chimneys, we used to write the programs in Fortran. I remember that Fortran program used to be there, and also some of the experts, like in the chimney experts, I used to have one Mr. N. Prabhakar. He used to write the program in the basics, and the design of the chimney is so well written in the course that it is possible for us to make a program even in the Excel using the macros. It is so very well defined and very well laid out in the course. There's no.
I think in my younger days,
Yes.
remember having seen a program in MapCat.
Yes,
for
MathCAD.
chimney.
Yes. And Iyer says that our course, they do not specify the design life. I do not know that. I think normally we have got 100 years return period we use for the seismic as well as the wind. And since we are using that, I think it is for the 100 years. I do not know. IS 456, Alok, does it give the service life?
Not in the previous one, but the one which is about to come, it talks about service life.
I say 100 years, right?
No, it is different for different category of, now they will have, different categories of structure, and they will have different design life.
But so far, they have worked based on 50 years life.
Yes, but it was not stated in IS 456-2000, but now it will be very categorically stated. And accordingly, the durability criteria will be set.
Yeah. And how much is concrete cover of RCC chimney was? Vinay, remember that?
30 millimeters.
No, 30, I think it's all, it depends. I think it depends from the specification to contract specification to.
Contract and this durability based on the environment there. But I remember 30 we have certainly designed. It looks too little to me nowadays.
Again, I think Mr. Joel is asking what are the advancement in the design of chimneys from last 100 years. I said that the advancement is a borosilicate lining. We don't require the platforms. The lining is stuck to this windshield. That is one. And the other is FGD chimneys. These are the two advancement what I can recall basically. And Ravindra Shah, I think, is asking, normally the designs are, I think it's never ending. It's going on. I think people are really interested in asking a lot of questions. Vinay, I think let us try to address all the questions. Ravindra Shah is asking, normally the designs are made before, and I have never seen designer making drawing as per the construction methodology. Hence, the designer needs to take into account the above issues as there is hardly any interaction. I think that I agree with Mr. Shah. Always, any structure for that matter, it's not only chimneys, any structure for that matter, I think constructability has to be taken into consideration. Construction sequence has to be taken into consideration while designing the structure. I think it's very important. Then only the structures can be constructed easily. I think that I agree with Mr. Shah there. The height of the nearby structure are around 70 to 80 meter. Flue gases and condensate from FGD chimney having a height of 120 meter may corrode nearby structures. What is your answer to that, Vinay? Because the height of the nearby structure is around 70 to 80 meter.
Right.
Flue gases and condensate from FGD chimney having height of 120 meter may corrode nearby structure. See the principle of, like the exit velocity, what they calculate, 25 meter per second, all 25 meter per second normally is that whatever the emission, of the waste gas emission, which is going to be there, has to be thrown into the environment, and it should not come down to the level of the ground, affecting or the hampering the health of the people at that level. That is the idea. From that point of view, only the height of the, whether it's a FGD chimney or other type of the chimney, height of the chimney is decided, and also the exit velocity is decided. Both are decided depending upon the gases which has to be emitted to the environment has to go up. It should not come down. That is the idea. I think that has been covered in deciding the height of the chimney as well as the exit velocity. I think that should answer your question, Mr. Asthana. Ravindra Shah again asks, normally the slip forming is being carried out from top of the foundation only. No company does shell construction by conventional method from top of the foundation to ground level. We do not insist on starter in our projects, not needed. Fine, Mr. Shah, no argument on that. I think if you are convinced it is not required, I think you should go ahead with that, and there should not be any issue. But your objection is that the designer is insisting for the starter. That is where you find the problem. That's what your objection is. What I could see from this is, I think if it's possible for you to do the slip forming from the top of the shell itself, top of the foundation itself, that's good enough. You should go ahead with that if it is not creating a problem.
No design issues, at least.
No design issues there. Abhijit Onkar is asking, we have done proof checking of a precast chimney in India. I see, that's a good news. That's good to know. And precast chimney, I do not know whether vertically the annular shells were cast and vertically prestressed, or what is the connection between the two precast segments. It will be interesting to know those details, how it is done, if it's already done. There's a very interesting question from Dr. Subramaniam Narayan. I think it must be almost around early in the morning there. Where is he? In the United States of America. Just for information, he says, Professor Peterson of Technical University Bundwehr, Germany, has worked on dampers which are mounted outside the steel chimneys to reduce the vibration.
Okay.
That's a good information. I think Dr. Subramaniam, thank you for that sharing that information. And also he comments that the Professor Manohar's book is very good, excellent. He says that we don't dispute on that. We fully agree with you, Professor Dr. Subramaniam. Rakesh Shah says, how many suppliers for borosilicate lining are there in India? I know one, that is Hedex is one that they have been what they call is as a pen guard liners, and they have been advocating. I think if you go to this go to the websites, you can see a lot of information on that. I know only about Hedex as well as the pen guard. Parthsarathi Bandopadhyay say, thank you for a nice presentation. Bouquet, please accept the bouquet from Mr. Vinay. And finally, I think Mr. Jael is tired. He has asked the last question. Is polluting the atmosphere same as polluting the rivers with the pollutants? In fact, the polluting the atmosphere is much worse because the climate change is totally taking place because of the pollution of the atmosphere, the carbon dioxide and other greenhouse gas emission to the environment. And you can say that it is the same, but in my opinion, it is worse because it is causing the climate changes, and climate action is warranted to overcome this climate change effects, after effects. So it is much worse. And whereas the pollution of rivers, I think it is in our control. Basically, I think it's possible for us to avoid polluting of the rivers, by strict measures. but the environmental pollution, I think it's very difficult to convince many of the countries. In fact, it's not only the people of the effects of the climate change. So I think that's more serious in my opinion. With this, Vinay, and we have come to the end of the questions which is there in the question and answer box. Normally, we do not take the questions which is there in the chat box, and also we have run out of the time. It was an excellent presentation. I should once again thank you for coming and making this wonderful presentation today. And with this, I'll hand over this virtual podium to Dr. Dhawan, if he's there for final closing up of the final remarks and closing up our webinar. Dr. Dhawan, you're there? No, Dr. Dhawan doesn't seem to be there.
He is muted.
He's muted, I think. So, Alok, I think if you would like to close this.
Alok, you are also muted, keep in mind.
Okay, so I think we had an excellent presentation today from Vinay. Such a lucid presentation, very rarely I find, and though the subject, I had very little knowledge, but I am today enlightened. Thank you, Vinay. And we look forward to more such presentation from you. I thank also Mr. Dhawan, Dr. Dhawan rather, because, though he is very young, but, the way he makes sure that, we have this every month, a technical lecture, that is amazing. And I don't know, I do not know what is in store for the next month, but I am sure he has somebody in mind and we will let you know. A lot of thanks to our participants. I think we get a lot of support from them. Any webinar or any refresher course that we do, we always get the support from the participants. Thank you for supporting IES Struct T. And I see now Dr. Dhawan come for giving the concluding remarks, sir. Before I hand over to you, I just want to thank our moderator also, Mr. Hegde.
Vinay, great day for us. And then our thanks to Hegde Saab and Vinay, who have spared valuable time for the benefit of 500 participants. I'm sure this monthly lecture will help the young ones to know more and more. Now, the more important, the next month there is going to be very important lecture on the against latest mode of construction practice like beams and the other things by our L&D lady. She has accepted and giving her willingness. And the next month we have got again Mr. Hegde, who will be talking. So every month we'll have some good speaker. So I mean, and then that will continue now. So far, this mode, then we can think of having the other mode where direct as well as this may continue. So thank you everybody, and thanks to the speaker and Mr. Hegde and the other organizers for sparing their valuable time. So thank you so much. Thanks once again.
Thank you. Thank you.